For section 2.7, we're going to talk about absolute value functions and transformations, and we're going to learn how to graph absolute value functions by hand. Since you've already done this on the graphing calculator, it should be fairly easy for you. So I'm going to go through this fairly quickly, but feel free to pause at any time. So an absolute value function is something that uses absolute value symbols such as f of x equals the absolute value of x. Now that is called our parent function. So I'm going to underline that because that's important. You might see that in the book or on a worksheet or anything we do in class. A parent function is like the basic function. So y equals the absolute value of x, or f of x equals the absolute value of x, is our basic function. So remember, with absolute value, I could have, if let's say I plugged in 3 for x. Okay, the absolute value is 3, but there's also another number that has an absolute value of 3, which is negative 3. So that's why when you graph these, it makes a V shape, because this graph on the right side is y equals x, and this graph on the left side is y equals negative x. Because if I plug in negative 1 for x, the absolute value of negative 1 is still 1, so I end up over here. But if I plug in 1, the absolute value of 1 is also 1. So that's why when I graph it, an absolute value function, it makes a V shape. Now the vertex is either the highest or the lowest point on the graph. So it would be, the vertex of this graph would be the point 0, 0, because it's the bottom or the top of our V is the vertex. Now, a transformation is a change to a graph size, shape, position, or orientation. So in using the graphing calculators before, we learned about a couple of different types of transformations. One is called a reflection, and that is when the graph actually flips over the x-axis upside down. Okay. The second kind was a translation, and that is where the graph moves either left or right or up or down. Um, it also changed size, because sometimes you learned that there were graphs that stretched, so you could have a stretch where it got skinnier, or you could have also a compression where the graph got fatter. So if you think about clip art, when you stretch clip art, it gets taller and skinnier, but when you like make it, you try to shrink it or compress it, it gets fatter or wider. So I think, let's see, that would be all the different types that we learned about using the graphing calculator. So again, a translation is when you shift it either vertically or horizontally, so that would be left or right or up or down. But the size and shape doesn't change when you do a translation. Now we can have a stretch or compression paired with that to where you'd see more than one of those things, but generally translations just move it left or right or up or down. Now this formula or equation, y equals the absolute value of x minus h plus k. This is the general format of an absolute value function. And looking at the numbers in that formula will tell you what happens to the graph before you graph it. So this is the graph of y equals the absolute value of x, but it translates h units horizontally, which means that h moves it either right or left. Okay, and then it translates k units vertically, which means it either goes k units up or down. Okay, the vertex of this equation is always hk. Now notice, h, there's a minus sign in front of it, which means that h is always opposite of what you think it is. So if h has a 2 right there, even though it looks like minus 2, the h is actually a positive 2. So that's kind of confusing. So we'll do some more practice with that. So here's just a visual for those of you guys that like pictures. So here's our graph of y equals the absolute value of x. And then if I have y equals the absolute value of x minus h plus k, it would shift h units to the right and k units up. Plus means that you're going up if you're on the outside, and minus on the inside of these symbols means that you're going to the right. So minus k would mean that you're going down, and plus h would mean that you're going left. So you have to pay attention to that. Hopefully you noticed those patterns when you were doing the graphing calculator activity, though. So we're going to graph the equation y equals the absolute value of x plus 4 minus 2. So let's just look and analyze this equation before we even start. Okay, let's think about what would be my h and my k. So this number would be h and this number would be k. Now remember, this symbol is supposed to be a minus in here. So since it's not, that would be like having minus a negative. Okay, so actually h is going to be equal to negative 4 and k is going to be equal to negative 2. So that would be the vertex of my graph. The other thing that you can pick out from this is plus 4 means that I'm moving which direction? Now, because it's plus 4, you would think that it would be to the right, but actually, because it's an absolute value, it's actually different than what you think. So, it's actually to the left. So, I'm going to be going left 4, and negative 2 on the outside of the absolute value symbols means that I'm moving down 2. So, first we did our vertex. The vertex was the point negative 4, 2. We got that from our h and our k. Now, the slope of 1 you get from whatever number's in front. Because there's not a number in front, this is a 1. So this number in front represents your slope. So what we're going to do is we're going to start at the point negative 4, negative 2, because that's our vertex, and then our slope is a 1. So we are going to just go up 1 over 1 and make our V shape from the point negative 4, negative 2. You can also always just plug in numbers for x. If you don't know how to graph this, just plug in numbers for x and then just keep plotting your points and you'll see the V. So if I was to graph this, I would start at the point negative 4, negative 2 right here. And then my slope is a 1, so I would go up 1 over 1, up 1 over 1, up 1 over 1. And then I would do the same thing to make my V shape. So then I end up with this red V right here. Now it says to compare this graph with the graph of y equals the absolute value of x. Well, that is at 0, 0. So what I did was basically I took this same graph, but I went left 4 and down 2. So that's when they say compare the graph, that's what they're asking for. They're asking how did it transform. So you have to tell which direction it moved, if it stretched or compressed, and things like that. Now let's talk about stretches, shrinks. This is also called a compression, and reflections. So the number in front of the absolute value tells you if it stretches, compresses, or reflects. So if the absolute value of A, which is just the number without the negative sign in front, if that number is greater than 1, it is going to stretch. Okay? If this number is less than 1, like a fraction, then it is going to shrink or compress, and that would be wider than normal. Okay? This one, if it stretches, it gets narrower or skinnier. If it shrinks, it gets wider because it gets fatter. If you take clip art and you shrink it down, it gets fatter and wider. Okay? So let's take a look at an example. Oh yes, and if A is negative, then the graph is reflected. So for instance, if I had y equals negative 1/2 times the absolute value of x, the negative sign in front means that it is reflected. So it's going to be upside down. The 1/2 since that is less than 1, means that it is going to compress or shrink, okay, by a factor of 1/2. So that's what that means. So let's look at another example. Oh, look, I just did this example. So it's going to be reflected because it's negative, and the 1/2 is less than 1, so it's going to be shrunk by a factor of 1/2 or compressed by a factor of 1/2. So you need to put those two things. Okay? The positive 3 in front means that it's not going to be reflected. It's going to be right side up. And this number is greater than 1, so it's going to be stretched. So this is going to be stretched by a factor of 3. All right, so let's look at multiple transformations. So here's my equation, and this is what I want to graph. Okay, so let's look at all the things we know. So first, let's find our vertex. If I look at my h and my k, my h is 1. Remember, it's not negative 1 because that's supposed to be a minus sign. So this would be 1 and 3. So that's my vertex. So this number in the middle is always opposite of what you think. So it's actually a positive 1. Okay? Then that means that I'm going to go over 1 to the right and up 3. So I'm going right, oops, sorry. I'm going right 1 is not wanting to cooperate. Right 1 and up 3. Okay, so on your graph, when you graph this, you're going to go right 1 and up 3. And that's going to be your vertex. Okay? Then I need to decide if it's going to be reflected, is it upside down, or is it right side up? Well, there's a negative sign here, so it is going to be reflected. So it's going to be upside down. My slope is a negative 2, so it's going to go down to right 1, down to left 1. And so my V shape is going to look like this. Now notice it's skinnier than normal because I have a 2 right here. So this is also stretched by a factor of 2. So let's go back through the steps again. First we identified the vertex, which was 1, 3. Then we plot other points by using our slope of negative 2. So that means it goes down 2 and over 1 in each direction. Now remember, you can always plug in numbers for x. So if you get stuck on the test, just plug in numbers for x and graph the points. So if I was to plug in 2 for x, then I would have 2 minus 1, which would be 1, and the absolute value of 1 is 1. And then I would have negative 2 times 1, which would be negative 2, plus 3 would be 1. So if I plug in 1, I get 1. So I would graph the point, or I'm sorry, if I plugged in 2, I would get 1. So I would graph the point 2, 1. If I plugged in 0, 0 minus 1 is negative 1 times negative 2 would be positive 2. Hold on, let's look at that again. So 0, let's plug that in. We have negative 2, 0 minus 1 plus 3. So 0 minus 1 is negative 1. The absolute value of negative 1 is 1. So we end up with negative 2 plus 3, which equals 1 again. So if I plug in 0, I get 1 again. So that would be this point here. So like I said, if you don't know how to graph it, just plug in points and you'll still be able to see your V shape. Okay, last thing. Transforming functions in general is the same as transforming absolute value functions. So the same rules apply. just instead of having absolute value symbols, we're going to have a function in here. So we're going to do two things. We're going to do 2 times the function of x, and this graph right here is our original function of x. It can be anything you want. It doesn't have to be a v shape. It can be a line. It can be anything that you want. So this is our function. We're going to multiply this function by 2. We're going to stretch it by a factor of 2. Now when we stretch it, when something is stretched, is it stretched vertically or horizontally? Right, when we think of stretched, it's stretched vertically. So the vertical points are your y's. So to stretch this by 2 vertically, you're going to multiply the y's by 2. So if I multiplied all my y's by 2, I would get the points 2, 6, and then 5, 6, because I'm multiplying 3 times 2. Sorry, 6. Then 0 times 6 would still be 0, 0. So that stays. So for that one, we are going to graph these points, and that will be the answer. So if we stretch the y coordinates by 2, we're graphing the points 2, 6, 5, 6, and then 0, 0. So this just stretched my function that I already had here. It stretched it by 2. Okay? Now, if we look at this, if you think of these as your absolute value symbols, okay, remember, negative means it's going to be upside down, and the 2, 1 means that this is going to be a negative 2, and this is going to be a positive 1. So that means that it would go left 2 and up 1. So we're going to shift all of our points left 2 and up 1, but before we do that, we're going to make it opposite. Okay? So because it has a reflection over the x-axis, first you would multiply all the y coordinates by negative 1, because if I want to do the opposite of this, I'm just flipping it upside down. Okay, so it's not going to go like way over here. It's going to be at the points 2, negative 3, 5, negative 3, and then 0, 0 would stay the same, because if that flips, it's still on itself. Okay, so that would flip it over. Then after that, I'm going to take each point and I'm going to go left 2 and up 1. So let's practice this. I'll show you, and then I'll show you the end result. So here's our graph. So I have, this is my original function, 0, 0, 2, 3, and 5, 3. So this is my original line. Now I'm going to switch colors, and I'm going to graph what that would be like reflected. It would be flipped. So I would still have 0, 0. I would have 2, negative 3, and I would have 5, negative 3. So this would be what would happen after it flips. So it's flipped over. Okay, but then I'm shifting it 2 units left and 1 units up. So I'm going to take each point and I'm going to go left 2, up 1. Left 2, up 1. And then left 2, up 1. So this right here is actually going to be my end result right there. Now, if you wanted to get those points algebraically, what you could do is you could add negative 2 to the x, because the x makes it go left or right, and you could add 1 to the y's, because that makes it go up or down. But I like to think of it as a reflection and then a shift left and a shift up, because it makes it easier to figure out. So again, this solid red line is what you end up with. Now make sure you answer your essential question with your summary. So if we go back to that really quick, how do I graph absolute value functions? So think of what steps you would use to tell someone how to graph an absolute value function.